Assuming we have a rigid body with a center of mass at point A, and let's say we have external forces acting on this body. Because the body is set into motions, we also have the force acting at the center of mass, and we call this one inertia force. The main principle of this method says that the resultants of all external forces acting on the body minus the resultants of the initial force is equals to 0. This looks like the conditions of static equilibrium, but because the object is moving with accelerations, we call this one dynamic equilibrium. The easiest way to remember this principle is that the resultants of external force is equal to the resultants of the initial force. Note that point A is the center of mass or the center of gravity. So if the center of mass is moving with translational displacement x as a function of time, therefore the initial force is mass of the body multiplied by d2x over dt squared, or mass multiplied by its acceleration. Similarly, if we now have the rigid body with external forces and the body rotates around the center of rotations O, we have the resultants of moment at that point O. Using the same principle, the resultants of moment due to the external forces is equal to the resultants of the inertia moment. Note again that O is the center of rotations. So if the body is rotating exactly at the center of mass with the rotational displacement theta as the functions of time, the resultants of the initial moment is the second mass moment of inertia of the body multiplied by its angular accelerations. This principle was proposed by Jean Leroux d'Alembert in the 18th century. He was a French mathematician, physicist, and also a philosopher. The principle is well known as Dalembert Principle. Okay guys, in the next video we will see how we are going to use this principle to derive the equations of motions.